Okay, so here we are again on our little rocky beach. And, oops, we are going to talk about chapter 1.4, which is building functions from functions, or sometimes this is called composite functions. And there's some new symbology. I don't know if that's the right word. We'll get rid of this. Don't save. So there's some things we're going to do with functions. So if I write f plus g of x, what that means is f of x plus g of x. If I write f minus g of x, and that's going to be, as you surmise, f of x minus g of x. If I do f times g of x, that'll be f of x times g of x. And surprisingly enough, f divided by g of x is, what a surprise, f of x over g of x. Okay, this is the kind of thing we're going to do with these functions, is we're going to do function math. Okay, and so you want to have this somewhere. There's a much more elegant presentation of this in the book that doesn't involve my messy writing. But you can see once you recognize the nomenclature on the left side of the equation, you're going to know what to do. So it's not terrible rocket science. I wonder if you ever do this kind of stuff on a rocket. No wonder. Okay, so let's say f of x equals x squared. And g of x equals square root of x plus 1. And I want to figure out, oops, f plus g of x. And I want to figure out f minus g of x. And I want to figure out, oops, f times g of x. And you know what would be really fun? Yeah, f over g of x. So I'm going to figure out all of these, okay? So first one, f plus g over x. So f of x plus g of x, so that's going to be x squared plus square root of x plus 1. We really can't simplify this at all. That's what we're going to get. And by the way, I'm going to mention it now and mention it a bunch of times. Square root of x, square root of anything, is the same thing as x plus 1 to the 1/2 exponent. 1/2 is the same thing as square root. True story. Okay, next one. F of x minus g of x. So that's going to be x squared minus square root of x plus 1. And again, can't do nothing. So we'll just leave it alone. Next one. F of x times g of x. So that will be x squared times square root of x plus 1. And we can't do a lot of simplification there. Would we want to bring this inside the square root sign and end up with something really big in here? Probably not. We would just leave it alone. So far you're thinking, this looks pretty good. I can do this. Easy peasy. And you're right, it is kind of easy. Last one, f over g of x. We're going to need some more room for this one because this one is not, I think we can fit it in here. So we can't divide x's and just leave a 1 down here or something. We can't interact with this stuff at all. However, so you would think this is simplified. However, we cannot leave a square root in the denominator. And if we had 7 over square root of 2, I would expect you to multiply by square root of 2 over square root of 2, and you'd get 7, oops, that is not a 7, 7 radical 2 over 2. This is the proper form. Let me do it in red so it's scary. This one is not the proper form. You have to rationalize the denominator by multiplying by the square root of the thing that's down here. So likewise, over here, I'm going to multiply by square root of x plus 1 over square root of x plus 1. And that's going to give me in the numerator x squared square root of x plus 1 over square root of x plus 1 times square root of x plus 1 is just x plus 1. Can these cancel? No. You would have to cancel an x out of everything in the denominator, not just one of the pieces of the denominator. So that's the last one. Does this make sense? We're just applying the algebra that it says, and whenever we do this one, we need to look to make sure if we have to rationalize the denominator or not. How often do you think you'll have to rationalize the denominator? Yeah, a lot, because students forget to do this, and so it's important when you get into calculus, and so I'm going to make sure you know how to do that by being really, really annoying with it. Okay, so that's function algebra. Now we're going to talk about composite functions. And these could be written as f of g of x, or it could be written as f g x. Little open circle, fog. Not times, you got to have that open circle, not a dot, so it looks like times. So this means, well, first of all, f of x means whatever number I'm going to use, I'm going to plug it everywhere I see an x. So f of 2, oh, there's an x. I'm going to fill it with a 2. That's what a function means, is whatever is in the parentheses here, the independent variable, take that number and jam it in wherever you see your independent variable x. It's the same thing over here. This is much easier to understand. I rarely ever use this form. I like this one. So if I have f of x equals x squared and g of x equals x minus 2, well, this says take what's in parentheses here and plug it into f wherever you see an x. That's what it says over here. If I put a 2 in here, plug in 2 everywhere where you see an x. So over here, I'm going to use the thing I'm going to plug into the function f is the function g. I'm going to take the function g and plug it in wherever I see an x. So I'm going to do f of g of x is going to be x minus 2 squared. I took x minus 2 and I plugged it into the function f of x. So I replaced this x with x minus 2 and boop, I got that. Okay? Now we can do it the other way. I can ask you what is g of f of x. And that means I'm going to take this function, and wherever I see wherever I see an x in the function g, I'm going to replace it with this function. So I'm going to take that and I am going to stick it into there. And that's going to give me x squared minus 2. So I had f of x and I had g of x. Oops. And I plugged this into the function f to get that. And then likewise, I took this and I jammed it in there for doing g of f of x. So the one on the inside is the one we plug into the one on the outside. That's always the case for composite functions. Okay, so now let's talk about domain of composite functions. So if I have f of x equals x squared minus 1, are there any restrictions on this? Can we use any value of x? Is the domain all real numbers? Let's see, when I hear the word domain, I think 1 over 0 and square root of a negative. These are the only places where I get in trouble. I'm not allowed to take the divide by 0. I'm not allowed to take a square root of a negative number. Are either of those possible here? Absolutely not. So the domain of f is just all real numbers. And then g of x, I claim, is square root of x. Aha! Now we have some restrictions. We can't put negative numbers in here. So the domain of f is, oops, x equals all real numbers. Here, the domain of x is x greater than or equal to 0, right? It could be 0, it could be 1, it could be 2, it can't be negative 1 because we're not allowed to do this. But now if I figure my composite function, so I'm going to take g of x and I'm going to plug it in wherever I see an x. So I'm going to write this as square root of x squared minus 1. What's the square root of x squared? Oh, that's going to be just x, because the square root function and the squaring function kind of undo each other. What's the domain here? Well, it's just going to be all real numbers. Oops. X equals all real numbers. Because I can't divide by 0 and there's no square root sign. So the domain for the composite f of g of x is going to be all real numbers. But if I do g of f of x, g of f of x, so I'm going to take f and I'm going to plug it in wherever I see an x in the function g. I say, so here's g, so I'm going to take this and I'm going to plug it into g. So I'm going to get the square root of x is going to be x squared minus 1 now. I'm going to replace x with x squared minus 1. And now, what's the domain of this? Well, the domain would be x squared minus 1 has to be greater than or equal to 0, right? Because I can't have a negative. So all of this has to be greater than or equal to 0, or x squared, I add 1 to both sides. Here's the domain for g of f of x. Does that make sense? So you go through and we can look at this and we can make sure, oh wait, let's see here. Hold on. X squared has to be greater than or equal to 1. But that means if I plot this on the number line, it could be 1 or it could be greater than 1. So here's 1. It could be 1 or it could be greater than. But what about negative 1? Could I use negative 1 in here? Yeah, negative 1 squared will work. So if I'm over here at negative 1, I could use negative 1, I could use negative 2, I could use negative 3, I could use all of those numbers. So the way we solve this algebraically is if I have x squared greater than or equal to 1, when I take the square root of both sides, one of the solutions would be x greater than or equal to 1, and the other solution would be x less than or equal to negative 1. That's what you do when you take a square root with with inequalities, okay? And so is that what I got? Yeah, x is greater than or equal to 1, that's this side. And x is less than or equal to -1. Less than means farther away from 0. When you're moving in the positive direction, you're getting bigger. In the negative direction, you're considered smaller. So this side is this side of the graph. And that side is this side of the graph. So this would be the domain. That's how we need to report it. We can't report it as a function. That was a silly thing to do. We have to do it this way. Okay, does that make sense? So let's say we have here's problem 17. F of x is x squared minus 2, and g of x is x plus 1. So what is f of g of x? And what is g of f of x? Okay, so f of g of x. I'm going to plug g of x into f. So f of g of x is going to be, where I see x, I'm going to plug in that. X plus 1 squared minus 2, which is the same as x plus 1 times x plus 1 minus 2, because we have to FOIL this. We can't leave it like that. So we'd get x squared plus x plus x plus 1 minus 2. So we'd get x squared plus 2x plus 1 minus 2 is minus 1. Okay, so there's one answer. Now we do the other way. G of f of x. So I'm going to take g of x and I'm going to fill x with f of x. So I'm going to put this into x. And I don't have to do much here. This is going to be x squared minus 2 plus 1. We're going to get x squared minus 1. And what's the domain? What's the domain of this? Can I divide by 0? Nope. Can I take a square root of a negative number? Nope. So the domain is x equals all the real numbers. Over here. Domain. Can I divide by 0? Nope. Can I take a square root of a negative number? Nope. So this is fine. This is, the domain is still all the real numbers. Okay? That was fun. Okay. Let's look at decomposing composite functions. So this is kind of fun because it's like a puzzle. So if I have a function, y equals square root of x squared plus 3 minus 1. And I claim this is a composite function. What are the two functions? So I got to look at this and I got to think, what is being substituted into something? And it looks like this is getting substituted into something. So I'm going to claim that this is f of g of x. And g of x equals x squared plus 3. That's what's getting stuffed in there. And f of x is square root of x minus 1. So this looks like I took this thing, g of x, and I stuffed it in here to get that. Does that make sense? But that's not the only answer, because I could have said, oops, g of x was equal to x squared, and f of x is equal to square root of x plus 3 minus 1. So now I would plug this into my x, and we'd get x squared plus 3 minus 1. So when you're doing the decomposing composite functions, there's actually multiple answers to it. And so you just got to be creative about it, and you got to look at it and think, what's the pattern here that I see, and how can I separate it into two different things? Okay, so here's f of g of x equals x plus 1 squared plus 3 times x plus 1 minus 4. Okay, you got to ask yourself, what's the thing that's being put into the function? And I'm going to say the thing that's getting put into the function is x plus 1. And if that's the case, then f of x, let's see, here's 1 here, so we're sticking them there, so that must be an x squared, because we're putting x plus 1 into there, and it has a square outside of it. And this must be 3. I'm putting an x plus 1 in here, so that must be an x. So this would be the two functions. Now, are there other ways to write this? Yeah, there probably are. But that's the simplest, I think. And so that's one that we want to keep. Let's see if there's another example. I actually, oddly enough, really enjoy doing the decomposing. Here we go. Yeah, this one's pretty easy. They're pretty easy because usually they're not multiplied out. On that last one, if all those terms are multiplied out, then forget about it. It's really hard to figure out. So this is number 23 in the textbook. F of g of x equals square root of x squared minus 5x. So I'm going to think g of x. Why don't you pause it, pause the video, and see if you can't figure out what g of x and f of x are going to be. Okay, ready? Pause. Okay. So I bet that the thing being plugged in is x squared minus 5x. Right, the thing under the square root sign. And f of x is probably square root of x. So these are the decomposed functions from this thing. Okay? Is that the only answer? No, I bet you could figure out, like, if f of x was square root of x plus 1, then g of x would have to be, well, I added 1, so I probably have to take away 1. Right, so when I plug this into here, the 1s are going to cancel and we'll still get that. So you can see there's an infinite number of solutions here. I try to not find the most difficult one. There's always a student who tries to find the most complicated one, and good for you. You go. So if you enjoy that, it's kind of a fun puzzle sometimes. Okay, so that's section 1.4. Please come to office hours, and I'm going to be doing more example problems. So if you need help on the homework, I'm able to help you. The homework will be due at midnight, so make sure you save yourself time to do it and come to office hours and get help if you need it. If you start your homework at 11:30 and you need help, well, sorry, you're out of luck. I can't help you then. I'm asleep. So come to office hours and get help. It's very curious how very few students come to office hours in the past. And maybe in an online course, more people will come. I don't know. But usually I'm sitting there alone. And so when somebody shows up to office hours, um, they're getting my full attention because there's no one else there, or maybe there's one other person there. It's never a ton of people. So please avail yourself of office hours. If I was in college and I had my professors saying, I want to help, please come ask me to help, ask me for help, I would have done so much better. Most of my professors in physics were pretty unapproachable, and they were pretty terrifying, and I didn't want to go ask them for help because I felt like I was going to look like an idiot. Well, you might feel the same way, and I'm telling you, I've had the same experience. And come ask for help, because if you come get help, you're not going to feel like an idiot. You're going to feel successful, and feeling successful is much better than feeling like an idiot. So please come and ask for help, and I can help you through whatever problems you have. Okay. End of coming for help lecture. Bye.